Hello! Welcome back to Great Forest Solves LeetCode, and today we got another blind solve. I'm going to start splitting these into, it'll be in the title, either a live solve or a blind solve. They're both live, but blind I haven't looked at, and I'm going to try and do one new question and one old question when I feel like it, which ideally should be every day, but you never know. So anyway, we have a question in front of us. This one actually looks pretty tough, but we'll see if we can get it done. So we're approaching LeetCode 230, kth smallest element in a BST. So what this question is saying is, given a binary search tree and an integer k, return the kth smallest value in the tree. A binary search tree is just a type of binary tree where at every node, all the nodes to the left of it are less than that node, and all the nodes to the right of it are greater than that node. So it's really easy to search for a number, but I don't know about the kth smallest number. But anyway, let's look at these test cases. K equals 1 here, so the first smallest is just the smallest, so it gets the 1. And here it says k equals 3, so the third smallest is 3, because it's the first smallest, second smallest, third smallest. I'm going to take the second example, because it's got a little bit more juice to it. And I want to try and find a pattern. Because I'm looking at these, and I know that let me try this out. I know that at every point, all the nodes to the right are bigger and all the nodes to the left are smaller. I know that's true, which that also implies that the node furthest to the left is the smallest node. But that gets a little bit more complicated with this previous example where the leftmost node is the smallest number, but it's not the deepest most node. The one the furthest down is not particularly the smallest or really in any order at all. And I also know when approaching these tree problems, especially when you're trying to count a value or satisfy some property, the best way to do it is with traversal, and there's only really two main traversals to use, which is BFS and DFS. So I have to kind of see if one of those is useful here. Well, one of them will be useful here, but which one will be more useful? Because with the DFS, I'll go all the way down, and then I'll go this way, and then I'll go here. That's kind of the route. And with the BFS, I'll go boom, and then I go back out, and I go boom, and then I go boom. And I've got to think of a way where that can give me an ordering. Because we don't just want the smallest, we want the kth smallest. Well, let me see. I mean, with the DFS, we would... I wonder how this worked. I don't know. I'm going to start with something. So let's say we start at the top. I'm just going to throw stuff at the wall until something sticks. Let's say we have a deck here where we can push and pop from either end. And we do a DFS, and we know whether we're going left or right at every point. So when we go left, we add a number to the left of the deck, and when we go right, we add a number to the right of the deck. And what this would do if it was in DFS order is it would add the 5, 3, 2, 1. You see, but then we get to that 4, and there's no good way to like know that we want it there. Like what I just proposed would put it there. So I don't know if that's our solution. Yeah, usually these constraints, they help a lot with like sliding window or string based stuff, but I don't know how they help with this problem. Well, what if I did a BFS and I tried the same thing? Because then I would have the 5, and I would go 3, 6. But then I would get to that 3, and I'd want to do like 2, 4, which that would also not work. Also, is it the smallest? Yeah, it is the smallest value, not... Okay. I mean, I've never done a heap problem, but this does also kind of sound like a heap problem. I don't know the Python heap stuff, and I feel like there's a way to do this without a heap, but I guess another solution is to just traverse the tree in any way, add it to a min heap, and then pop k times and return, which that would work. So let me try that actually. So now what I'm proposing is I do just the depth first search, but every time I add that to a structure called like a min heap, which is a structure where it maintains, so like when you're popping an item off of it, it'll always give you the minimum item. And it does some reordering under the hood, uses a tree under the hood, but that's not important because we have a Python library for it. So like I would just traverse and add all of these numbers straight into my min heap, and then I could just pop from the min heap k times. And this should work. I don't know if this is the most optimal solution, but let's try it out. So to do this, I would just want a DFS helper function. So if left, we go left, and if right, we go right. And I need to actually do something, so what's the library again? I kind of forget. Heapq.heap. Or it's just a list, and then there's, yeah, okay. So we set up our heap like this, and then at each point in the traversal we go heap dot, no, we go heapq dot heap push, and then we send the structure, and we send the item. I believe that's it. Could be wrong. And then at the end, we would just want to return the kth value. So maybe there's a better way to do this, but I can just loop through and just pop k times and then return return the final one. Or maybe I'd have to pop k minus times, then I get the final. If I got all this, what's going on? Index out of range? I just don't know if I did, like, all of this correctly. Alright, I should be able to do this in an interview. Python heap queue documentation. I don't want the AI overview. Just give me the heap. Transform list into a heap. Push heap item. But do I need like a heap before I push the heap? Well, I was right. Wait, I was actually right. I didn't even need that. Unless I needed to like create the heap in the beginning. Heap queue.heapify. Is that gonna do it? No. I don't remember having to do that, because I've used a heap before, just haven't really studied these LeetCodes. So anyways, so in this scenario, we're doing this one, we add the 3, 1, 2, and then 4, all to my heap. And then I pop off, k is 1, so I don't pop anything. And then I pop the final item. But it's saying index out of range. And it doesn't like my return. Yeah, it doesn't like it. Pop and return the smallest item from the heap. Heap. Push. I mean, surely I don't think I need to import. What if I did this? Still saying index out of range. Am I popping something here? Because my heap should have stuff in it if I'm pushing. Maybe I'm accidentally popping? Oh, it still says... That's so interesting. Let me try printing this. It's probably just going to give me the error on that print statement. That's chill. Yeah, let me print just the heap. I want to see if I'm adding things to it correctly. At the minimum. Okay, so no, there's nothing in it. Heap push, heap item. Heap push. My heap. And my item. So what's going on here? Oh, I'm not calling... Dude, I'm not doing anything. Oh, that's a horrible critical error. Oh, man. I need to run this at the root. Here we go. This will help. Alright, yeah, now I'm printing stuff. And it worked for this because it's the first one, yeah, because then I need to pop k-1 stuff off. And then return this. Okay. I was so confused because I thought I was doing something and turns out I wasn't. Now, is this efficient enough to be accepted is the real question. And that I don't know. It is. Oh my god, was this the optimal solution? I guess you were supposed to use a heap on this. LeetCode threw me off because I was following his roadmap and this was in trees. By the way, this is where I am in the roadmap. So I thought it was like just like a tree thing. I wonder, like, is there a way to do it without a heap, or is that what he wanted as well? What do you got? Brute force? Oh, just sorting at the end? That actually makes sense. That's valid. He didn't use any heap. What's my complexity? I mean, it's gotta be pretty good to be... I wonder, is using a heap bad on this? I'm so confused. My memory also looks pretty good. Let's ask ChatGPT. I want to make sure. Because this turned a hard problem into one that seems almost too easy. Is this a valid solution? Interviews would accept. But I guess that is the beauty in using the right data structure for the job. It turns a hard problem into a significantly easier one, so... And I actually remembered the heap stuff. Literally, this is the only thing I didn't really do. Not bad. I'm gonna wait for this to analyze, and then I'll end it. I'll end it here. The video. Okay, we're back. I just paused the OBS recording so I don't have to edit this. But the plot thickens. It's correct, but not what they're looking for. Time is n log n. I guess that is worse than n. Totally works with past interview. See if you exploit the BST property. Oh, an in-order traversal gives you the values in sorted order. Actually kind of makes sense. I like my heap thing, and I bet I could get away with explaining how I just use the right data structure for the job. God forbid. But it's doing something I kind of forgot about, where you can, like, set up a recursive function, so you go down here, do something to this, and then down here. And then you can go down here, do something to this, down here, do something to this, down here. And I think that gives it to you in sorted order. I don't know, maybe I'm reading too into this. Just let me take my W, you know? Optimal. I'll do it recursively. So it calls the left branch, does something, and then calls the right branch. How does performing an in-order traversal give the values in sorted order? I guess this is interesting to understand. Every node in a BST, yeah, I explained this. In order 3, 1. Oh, so you go... Oh, okay. You go as far left as you can, and then... So, like, it would go all the way down until it couldn't, actually. It would go until null. There's, like, a null value here. Then it would compute this. Then it would try to go here, null. Go back up, see this. Then try and go here, null. Go back up, see this, go this way. Get this one, go back up, get this one, and then get that one. Okay, that makes sense. I guess that's good to know, but I like my heap, so I'll leave it at that. Until next time, see ya.